Welcome back again, solving numerical problems in physics, Pulley systems. I hope you have by now watched the previous videos where I explained Pulley systems and I derived few expressions and shortcuts how to do it quickly. And now we have a wedge like this. This is a wedge. This side is inclined, this side is inclined. Here is a pulley. The pulley is massless. The string going over the pulley is attached to a mass here and one mass here. Now, let this mass I take it as M1 and this mass I take it as M2. And I take this angle as alpha and I take this angle as beta. Now, whether this M1 will slide down depends not only on the weight of the mass M1g but also the sign of this angle. Similarly, whether M2 will come down not only depends whether M2 is the value of M2 is more than M1. It doesn't depend only on the value of mass. It depends on the component of M1g to this side and the component of M2g to this side. So let me first then find out which component of its weight is acting along this side and which component of this, the weight of this mass M2 is acting to this side. So for that, what do? I let the weight of this mass M1 is of course acting from its center of gravity mass. Let me consider it here, or you can consider it here, no problem. Now look, so this is the direction of its weight M1g. Now look, this angle is 90, this is alpha, so this angle will be 90 minus alpha. So I will be splitting this weight M1 times g to rectangular components. So what angle I must add to this angle 90 minus alpha to have 90 here? So to this side, if I add alpha, then if this is alpha, then this whole thing alpha plus 90 minus alpha will be 90, and since this side is adjacent to the angle alpha and this is M1g, so this will be equal to your M1g times M1 times g cos of alpha, and to this side will be M1 times g sin alpha. And that instead of showing here, I am showing it here. It's all right, you can show it anywhere you like. So this is your M1 times g sin alpha. Now M1 times g is a force, the weight. Sin alpha is a number. So force times a number is a force. So this is the force that is acting to this side on mass M1. Now similarly here, since this angle is taken as beta, the weight of this mass M2 will be vertically downward. Let me draw it here. So this is equal to your M2 times g, its weight acting vertically downward. And this angle is 90. This angle is 90. So this will be 90 minus beta. Let me show it here. 90 minus beta. So to this side, if I add alpha, then what will happen? So if this is your alpha, if this is your beta, then this whole angle will be 90. And this is beta, and this is your M2 times g. So this will be M2 times g of cos beta, and m2 times g sine beta will be along the inclined plane acting downward. So let me show it here. I can show it here, but since a vector can be shifted parallelly, let me show it here. So this is equal to your m2 times g sine of beta. Now if you look at the diagram now, I am not interested in this, I am not interested in this. This is the action force here, so there will be reaction force. Here this is the action force, so there will be reaction force to this side. Since there is no friction on this part and this part, I am not interested in this part and this part to find out the force of friction. This surface is smooth, this surface is smooth. So look at this string which is massless, which is passing over the pulley. It will have the same tension. For this part, for the mass m1, the tension will be away from it, and for this mass m2, the tension will be away from it. The same tension T, the same string. Now, if you want to write the expression for acceleration, you can write straight away. How can you do that? Supposing these two masses which I have shown here, you consider them as horizontal like this. So this m1 times g sine alpha at this point is to this side, and m2g sine beta at this point is to this side. So let me show here. So now, so this is your m1 times g sine alpha, and this is your m2 times g sine beta. Now, whether this mass will come down depends on the value of m1 g sine alpha. Means if m1 g sine alpha is more than m2 g sine beta, then only m1 will slide down. On the other hand, if m2 g sine beta, the value of this force is greater than the value of this force, then m2 will slide down. So in this case, I am assuming this m1 is coming down. You can assume this to come down also. So if you look at this diagram here is the tension. That is an internal force, so which I am not considering. And this is your m2, and this is your m2, this is your m1. So this is system consisting of two masses m1, m2, acted upon by two forces, m1 g sine alpha, m2 g sine beta. If m1 is sliding down, then this must be greater than this. So the net force on the system is m1 g sine alpha minus m2 g sine beta. So your acceleration, since we know F is equal to mass times acceleration, so acceleration is equal to F over F net force by mass net mass. So your net force is equal to m1 g sine alpha, minus of m2 g sine beta is the net force on the system divided by the total mass m1 plus m2. You can rewrite it so that this looks decent. So if you take g common, so we are left with m1 sine alpha minus m2 sine of beta over m1 plus m2 times g. Why do I write this way? This is acceleration on the left hand side, so the right hand side we must be acceleration. This is acceleration, so this part must be a number. Now how this is a number? Sine alpha is a number, sine beta is a number. Number into mass is mass, means kilogram. Number into mass is mass, kilogram. Kilogram minus kilogram is kilogram. And in the denominator also you have kilogram plus kilogram, kilogram. So the kilogram cancels. So we are left, this whole thing is a number, and number into acceleration is acceleration. But to find the tension, you cannot find in a shortcut way the way you found acceleration here. For tension, we have to write the equations and put the value of A in one of the equations to find the expression for acceleration. Now, if you look at M1, since I assume this is going down, let me, you can use this expression, put the value of M1, M2, sin alpha to find out the value of this acceleration. Now, assuming that this M1 is coming down, and if I put the values here, supposing the value of acceleration comes out to be negative, this means M1 is not coming down, M1 is moving up. That is to be understood. So let me now write the equations for the mass M1. This is acted upon by two opposite forces, one to this side and one to this side. Since I have assumed this is coming down, so M1g sin alpha must be more than T. So for M1, the equation becomes M1g sin alpha minus T is the net force on this. There is no friction. It will be its mass times acceleration, equation 1. Now, if you look at here, M2 is acted upon by two opposite forces, T to this side, the tension force, and M2g sin beta is to this side. Since I have assumed M1 is coming down, so M2 is going up. So the value of T must be greater than this. So the net force on M2 is equal to T minus M2g sin beta is the net force on M2. So that will be equal to its mass times acceleration. Why the acceleration will be same? The length of the string from here to here is not stretchable, right? So now there are two equations. Now to solve it, what I have to do is, whenever you will have two masses, you will have two equations. If you add them once, you will get definitely the value for acceleration. So if I add these two equations, I am adding it, minus T plus T cancels. On this side, if I take a common, I am left with in the bracket M1 plus M2. On this side, this minus this, I take G common. So you are left with M1 sin alpha, M1 sin alpha minus M2 sin beta times G is this. M1 plus M2 is multiplied here, so it comes to this side. So your acceleration becomes, M1 sin alpha minus M2 sin beta over M1 plus M2 whole times G. So this is the value of acceleration. Now let me repeat. I have assumed this M1 is coming down, and I have derived the acceleration here by using the equations. Here I am doing a shortcut, net force over net mass. If you put the value of M1, M2, alpha, beta, and the value of G, you will get some value. If this value comes out negative, then M1 is not coming down, is going up, right? Now to find the tension, let me take a different paper. To find the tension, I have to put this value of acceleration either in equation 1 or in equation 2. So let me do that. So let me put it in equation 1. So this is your equation 1. Let me rewrite it. M1g sin alpha minus T is equal to M1 times A, and this is your value of A. So if I substitute the value of A, G sin alpha minus T is equal to M1 times this acceleration, that is M1 sin alpha minus M2 sin beta over M1 plus M2 times G, right? Now we will solve it for finding the tension, right? We'll solve it to find the tension. So I take t to the right hand side becomes positive, this comes to this side becomes negative. So we are left with m1g sine alpha minus of m1g. I write here so that I can take common. So we are left with m1 sine alpha minus m2 sine beta over m1 plus m2. Now m1g here, so taking common m1g common, I am left with from here sine alpha minus m1 times sine alpha minus m2 times sine beta over m1 plus m2. So I take LCM, so m1g, so this comes here, will be multiplied here. So we have m1 sine alpha plus m2 sine alpha. Your LCM is equal to m1 plus m2. Now then this term here, but in front of that is a negative sign, so this will be minus of m1 sine alpha plus of m2 times sine beta. So your m1 times sine alpha, positive here, just negative here cancels. So we are left with m1g times within bracket m2 sine alpha plus m2 sine beta over m1 plus m2. Now how should, so if I take m2 common and I write g on this side, so I am left with m1 m2 over m1 plus m2 times sine alpha plus sine beta, and Ig right here. This is the expression for your t. Why I have arranged the terms containing m at one place and the terms containing sine at one place and g at other place, so that it looks beautiful, because this is a tension, this is a force, so the right side must be a force, and any force is equal to mass into acceleration. This is your acceleration, so this part must be mass, because sine of angle is a number, this is a number, number plus number is a number. Kilogram into kilogram is equal to kg square, kilogram plus kilogram is kilogram, so cancels. So this part is a number times mass is mass, so mass into g is a force, so tension is a force. So what I just derived for you is the following, that is I derived as m1 sine alpha minus m2 sine beta over m1 plus m2 times g, and the tension I derived as m1 m2 over m1 plus m2 times within bracket sine alpha plus sine beta times g, right? So this is your acceleration, this is your tension for such a system, two masses on a wedge. Now using this expression, I derived acceleration for this system on a wedge and also the tension in the string. Now using these two expressions as general expressions, we can very easily find what will be the acceleration for a system like this, for a system like this, for a system like this, or for a system like this. Now you can straightway use these equations by doing some modifications in the angles. Now what modifications have to be taken place? What modification have to be taken place in these two angles, alpha and beta, to arrive here, and for this system I have to explain it, then it becomes pretty easy. Now to do so, I have drawn another diagram for you. So this was your original diagram, and this was your M1, and this was your M2. Let me take the black pen. This was your M2. Now, and this here to this side, M1G of sine alpha, because I had taken this alpha, was acting to this side, and to this side was your M2G times sine beta was acting to this side, because this angle was taken as beta. Now is the understanding. Now, suppose this side of the inclined plane is not like this, is like this, then this mass is not here, then this mass is here, this mass is here, this mass is here, and this angle is not alpha, this angle is alpha. Again, suppose this side is not like this, is like this, then this mass is not here, is here. You have to make some imagination here, and this is not the string, and this is the string, this is the string, and this is your alpha. So as look, as the mass is coming down like this, the angle alpha is increasing. Now in this particular case, if you take this M1 and this as M2, this M1 is hanging straight down. So this, if this M1 is hanging straight down like this, then your alpha, which becomes 90 degree. Similarly, if M2 is hanging down, if M2 is also hanging down, your beta becomes also 90. Beta also becomes 90. So to come from this diagram, this diagram, using the final expression for alpha and the tension, we can for this situation we can put alpha is 90, alpha is equal to 90, and beta is equal to 90. Beta is equal to 90 in these two final expressions. I can use alpha as 90, beta as 90, alpha as 90 and beta as 90 to arrive at the expression for acceleration and tension for this system. So for this system, if I put alpha 90, beta 90, sine alpha 90, sine 91, sine 91, sine 91, sine 91. So here your acceleration becomes m1 minus m2 over m1 plus m2 times g, and your tension becomes, put alpha 90, beta 90, sine 91, sine 91, 1 plus 1, 2, that's 2 I write here. So your tension becomes 2 m1 m2 over m1 plus m2 times g, right? Or you can interpret in a different way. This mass is trying to come down and this is opposing, so it is subtracted here, m1 minus m2 times m1 plus m2 times g. Now uh, this is trying to come down, this is opposing, so it is subtracted. What I mean to say, if there is a system like this, let me draw another diagram for you quickly. If there is a system like this, suppose this is one mass, this is another mass, here is a pulley, and here is a mass. Suppose this is M1, this is M2, and this is your M3, and this one is coming down. So this is trying to come down, and these two are opposing. So minus M2 minus M3 over total mass M1 plus M2 plus M3 times G. You can write straight away. If this side is coming down, then you can write M3 plus M2 minus M1 over M1 plus M2 times G. So now let us come here. No, okay, let us come here, then we'll go back here and go back here. Let us come here first. This is also M1, this is also M2, and both are hanging down, hanging vertically down. Doesn't matter whether it is a single pulley or like this. So for this system, your alpha is equal to 90 and your beta is equal to 90. So by putting alpha is equal to 90, beta is equal to 90, in this expression, your expression for A and T for this system also remains same as this. Now look at this. On the right hand side, the mass I have taken is M1. On the left hand side, I have taken it as M2. So this is your M1, this is your M2, this is hanging down, and to this side the angle was alpha. So for this system, alpha is equal to 90, and the angle beta was taken on the side on which M2 was lying. Since this is not hanging, this is horizontal. Look, if this M2 is horizontal, if this M2 is made horizontal, when it is hanging, it is making angle beta here. If it is horizontal, then there is no angle, we have two parallel lines. So for this system, put alpha is 90 and beta is equal to 0 degree. In this expression, alpha is equal to 90, beta is equal to 0 to have the value of A and tension for this system. Now then come back here. Now this I have taken as M1 and angle on this side I has taken as alpha. Suppose this is given as 60 degree. And this is M2, and the side of M2 the angle was beta, and since this is vertically hanging down, so for this beta is equal to 90 and alpha is equal to 60. So alpha is equal to 60. So in this expression, put alpha is equal to 60 and beta is equal to 90. Substitute the value here and here to find the expression for acceleration and tension for such a system. Fine. So one more numerical problem that I will discuss. This one I will discuss later on, but I can explain you the value of acceleration immediately. Suppose this angle is alpha, this angle is beta. So if this is M1, to this side will be your M1. This will be M1 times G of sine alpha. If this is M2, to this side will be M2 times G of sine beta. If this is equal to M3, this one will be equal to M3 times G sine beta. So which I can show it here. So this is equal to your M1 G sine alpha, the tension T here, and here the tension will be different, let it be T2. So this tension I don't consider, this tension I don't consider because they are internal forces. And to this side is your your m2g sine beta, m2g sine beta, and to this side is your m3g sine beta, m3g sine beta. Now, supposing this system is coming to this side, so the net force will be m1g sine alpha minus this. So your net force is equal to m1g sine alpha minus of m2g sine beta minus m3g sine beta, net force over total mass is equal to your acceleration, right? Now to find the tension here, you have to use the equation for this. Now how you have to do, supposing this is coming down, so you write m1g sine alpha minus t will be equal to m1 times a, this a. Now for this, since this is going up, so T2 will be more than this, so you write T2 minus M3G sine beta will be the net force on this, so it will be equal to M3 times A, same A. Now to write the equation for this, since this is going up, so for this you have to write T minus T2 minus M2G sine beta minus M2G sine beta will be M2 times A. So we have three equations. You put this value of A here to find T. If you put the same value of A here, you find T2. So everything is found out.